So the equation of the circle that we found was this. Okay, let's now read the first part of the question. The coordinates of the other point in which the axis of y cuts the circle. Now, if you see which was the first point that the axis of y cuts, can you tell me which is the first point that the axis of y cuts? In which the circle cuts the axis of y? Which is the first point? If you see, the circle passes through these 3 points, P, Q, and R. So which one lies on the y-axis? This one. So this is the first point at which the circle intersects the y-axis. They are asking you what is the other point in which the circle cuts the y-axis, right? So what you do here is, if we call this equation as, let's say 5, because till that we had named it as 4. So in 5, in order to find the coordinates of the point, what do we have to do? We put, if we have to find coordinates of the point where the circle intersects the y-axis, we put x is equal to 0, right? So putting x is equal to 0 in 5, we get 2y square minus 7y plus 6 is equal to 0, right? If you put x is equal to 0, now we need to solve this quadratic equation to get our coordinates. So how do we factorize this equation? It's 2 into 3 minus 3 into minus 2, right? So 2y square minus 3y minus 4y plus 6 is equal to 0. That means y times 2y minus 3 minus twice 2y minus 3 is equal to 0. That means we get 2y minus 3 into y minus 2 is equal to 0. That means either y is equal to 3 by 2 or y is equal to 2. So what are the points at which the it cuts the y-axis? It cuts the y-axis at 0, 2. Therefore, the circle 5 cuts the y-axis at 0, 2 and 0, 3 by 2. Hence, the other point is, at which the circle 5 cuts the y-axis is 0, 3 by 2. Okay. So this is 7 part 1. That's done. Let's look at the second question here. The coordinates of the other end of the diameter through Q. Okay. And let's say this is our circle. Okay. And coordinates of the other end of the diameter through Q. What is the coordinates of Q? 3, 0. So let's say 3, 0 is one point on the circle. Let's say here. Okay. And let's say this is your center. You have to find out the coordinates of the other end of the diameter. That means you have to find out the coordinates of P. Okay. Okay. In order to find out the coordinates of P, we first need the coordinates of the center, right? Now we have already found out the value of G and F here, isn't it? So here, G, we have found this out to be, earlier we had found out G to be minus 2. And we had found out F to be minus 7 by 4. And we had found out C to be C to be 3. Okay, these 3 we have found out. So if C is the center of the circle, therefore what is the coordinates of C? Coordinates of C, center, is minus G minus F. is equal to C 2 minus 3, right? This is the coordinates of the center of the circle, 2 minus 3. So therefore, what should be
So
the
it will be 2
minus?
comma
Yes, yes,
minus
exactly.
7.
Minus G minus F, and therefore this is 2 7 by 4. So this will be 2 7 by 4. Okay, so let the coordinates of the other end. Now you know the midpoint. C is the midpoint. So by midpoint formula, you can find out. Let the coordinates of the other end of the diameter be PAB, let's say. Okay, so we are calling this AB. Since C is the midpoint, therefore coordinates of C is 3 plus A by 2, 0 plus B by 2, which is C 3 plus A by 2, B by 2, right? This is the coordinates of the center, and this must be equal to
2 comma 7 by 4.
2 7 by 2. Therefore, we get 3 plus A by 2 is equal to 2, and you get B by 2 is equal to 7 by 2. And therefore, you can solve this to get A is equal to 1, and you can get B is equal to 7. Okay, 7 by 4 this is, no? 7 by 4. 7 by 4. So this will be 7 by 2. Okay, so what are the coordinates of the other end of diameter? Therefore, coordinates of P is 1, 7 by 2. And that's your answer. Okay, any question? Or I can proceed with the next one. Okay. Be sure to do these questions. I'll be giving you exact same questions in the question paper, in third term question paper. Just know that. Whatever question I have discussed, I'll be giving you the same questions. Number 8. Look at this question. The radius of a circle is 5 units and it touches the circle x square plus y square minus 2x minus 4y minus 20 is equal to 0 externally at the point 5 5. Find the coordinates of find the equation of the circle. Okay, so you have two circles. Let's say this, and you have another circle. Say this. We make a bigger one. Yes, two circles which touch each other externally. Okay. Radius of the circle is 5 units. Let's say this radius here is 5 units. And it touches the circle x square plus y square minus 2x minus 4 minus 20. And the equation of this circle is x square plus y square minus 2x minus 4y minus 20 is equal to 0. Externally at the point 5 5. That means these two circles touch each other externally at the point, let's say, let's call it M 5 5. Okay, this point here. Find the equation of the circle. That means you will have to find out the equation of the circle. Let's call it this center as C1 and let's call this center as C2. So you have to find out the equation of the circle with center C1. Okay, that is the entire question. Now see, since the equation of the circle with center C2 is given, we can find out the coordinates of the center and also the radius, right? So the given equation of the circle is x square plus y square minus 2x minus 4y minus 20 is equal to 0. So comparing with the general form, we get 2g is equal to minus 2, we get 2f is equal to minus 4, and you get c is equal to minus 20. That means you get g is equal to minus 1, you get f is equal to minus 2, and you get c is equal to minus 20. So therefore, the coordinates of C2 is minus g minus f, which is equal to C2 1 2. So let's write it here. We know the coordinates to be 1 2. Fine. And also we should know the radius of the circle with center C2 is, let's call it R2, root over of g square plus f square minus c, root over of g square plus f square minus c. Okay, you can find this out to be 5 units. Okay, that means the radius of this circle here with center C2, this is 5 units. So that means C1m, this length here is 5 units, and C2m, this length here is also 5 units. Therefore, C1m and C2m both are equal to 5 units. So if both are equal to 5 units, then what can you say? Can you say m is the midpoint of C1, C2? Yes, we can say.
Yes, sir.
Okay. So therefore, m is the midpoint of C1, C2. Now, if we can say m is the midpoint of C1, C2, the question here is find the equation of the circle with center C1. That means we can find out the coordinates of the center of the circle C1 because m is the midpoint, right? So I say let hk be the coordinates of the center C1. So right here, C1 hk be the coordinates of the center, right? So therefore, what is the coordinates of m from midpoint formula? See that m is the midpoint of C1, C2. That means if this we have taken as hk, that means this will be coordinates of m will be h plus 1 by 2 and k plus 2 by 2. Okay, this is the coordinates of m. And what are the coordinates of m given? 5, 5. So therefore, h plus 1 by 2, k plus 2 by 2 must be equal to 5, 5. And from here, you can find out the value of h and k. It means you will get here h is equal to
9.
9, and you will get k is equal to 8.
8.
Okay, so we have got the coordinates of the center and we also know the radius, 5 units. So what should be the required equation of the circle? Hence, required equation of the circle is x minus h whole square plus y minus k whole square is equal to, radius is given 5 units, 5 square. And that is the required equation of the circle. If you want, you can express this in general form, expand x minus 9 whole square, expand y minus 8 whole square, and simplify this a little, take everything on the left hand side You will get x square plus y square minus 18x minus 16y plus 120 is equal to 0. Okay. So this was an easy problem. Now my question to you, if instead, suppose, if we had got the radius of this instead of getting as 5, suppose we had got the radius of this as, this is your C2 here. Suppose we had got the radius of this as 3 units. Now tell me how would have we found out the coordinates of C1? Luckily here we are getting M as a midpoint. But suppose if we had got radius of circle with center C2 as 3 units, then how would you have found out? Any idea? Anyone? No idea? Now see,
Mm,
if we had got this as 3 units, then C1M clearly is 5 units and C2M is 3 units. So therefore, what is the ratio of these two? C1M is to C2M? 5 is to 3, isn't it? Now with the help of section formula, we can find out. If we consider this as our x1, y1, and this as coordinates as x2, y2, then M is equal to 5 and N is equal to 3, isn't it? Then by section formula, we can find out the coordinates of M, and that must be equal to 5, 5. Clear?
yes, sir.
Okay. We move on to the next problem then. Number 9. Question here is, find the equation of the circle which passes through the points 5, 0 and 1, 4. So 2 points are given on the circle. Okay. Let's say these 2 points are given. Circle passes through 5, 0 and it also passes through, let's say, another point 1, 4. Okay. And whose center lies on the line x plus y is equal to 3. Suppose this is your center C. Then the circle must lie on this line. The center of the circle must lie on this line. What is that line? X plus y minus 3 is equal to 0. Okay. You need to find out the equation of the circle. Fine. So how do we find out? I start by saying let the equation of the circle be x square plus y square, because 2 points are given on the circle. So we start with this. Let the equation of the circle be x square plus y square plus 2gx plus 2fy plus c is equal to 0. Okay. Now, since 2 points are given, we say since, let's call this 1. Since 1 passes through 5, 0, therefore you have 5 square plus 0 square plus 2g into 5 plus 2f into 0 plus c is equal to 0. So you get 10g plus c is equal to minus 25. This is the first simultaneous equation that you are getting. Let's call it 2 because we have already called the equation of the circle as 1. Okay, this is the first equation you are getting. Now look at the next point. It passes through 1, 4. So since 1 passes through 1, 4, therefore it must satisfy the equation of the circle. Put x is equal to 1 and y is equal to 4. So 1 square plus 4 square plus 2g into 1 plus 2f into 4 plus c is equal to 0, which will give you another equation, which is 2g plus 8f plus c is equal to minus 17. Call this equation number 3. We have got a second simultaneous equation. Now the question is how to get the third simultaneous equation. See that we have taken the equation of this circle to be x square plus y square plus 2gx plus 2fy plus c. That means the coordinates of the center will be minus g minus f. So coordinates of the center, c, is minus g minus f. Now see that c lies on the line, since c minus g minus f lies on the line through the center, isn't it? The line x plus y minus 3 equal to 0. Therefore, it must satisfy. So instead of x, you put minus g. Instead of y, you put minus 3 is equal to 0. So you get here g plus f is equal to minus 3. This is your third simultaneous equation. We call it 4. Okay. Now we need to solve these three equations. Okay. Now the question is how to solve. Three equations, three unknowns can be solved. Definitely can be solved. But the question is how. See, uh, you have if you look at equation number 3, it has all g, f, and c. If you look at equation number 4, it has only g and f. If you look at equation number 2, it has g and c. That means from these two equations, from equation number 3 and from equation number 4, if I can remove this f, that is eliminate this f, then I'll only be left with g and c. Right or wrong?
Yes, sir.
Now, if I'm after removal of f, if I'm only left with g and c, then I'll get one equation in g and c. And what is the other equation in g and c? This one. So I can solve these two simultaneously to find out the values of g and c. And in order to find out the value of f, I can put the value of g and c in this equation back. Clear?
Yes, sir.
So what do I do? I remove f between 3 and 4. So eliminating f between 3 and 4 by multiplying 3 by 8, or rather 4 by 8. Um, we're multiplying by 2 simply, isn't it? Yes, g plus f is equal to minus 3, and this is 2g plus 8f. Okay, so this is g plus f. Yes, so multiplying by 4 by 8. 4 by 8 and subtracting from 3, we get 2g plus 8f plus c is equal to minus 17, and you get 8g plus 8f is equal to minus 24. Subtract, plus, you get a minus. This gets eliminated definitely. So you get minus 6g plus c is equal to 7. So that means you can write this as 6g minus c is equal to minus 7. Okay. So this is an equation. Let's call it equation number 5. Now we can solve this 5 here that we have got, and we can solve this 3. So solving 2 and 5. Then I don't need to show you how to solve. So just write solving 2 and 5. We get g is equal to minus 2, and you'll get c is equal to minus 5. Okay. Now once you have got the value of g and c, how will you get the value of f? Put this value of g and f in this equation number 3. So from 3, 2g plus 8f plus c is equal to 0. That means you get 8f minus 9 is equal to 0. That means you're getting f is equal to 9 by 8. Hence, what is the required equation of the circle? Required equation of the circle is x square plus y square plus 2gx plus 2fy plus c is equal to 0. This is the required equation of the circle. And you can simplify this to get 4x square plus 4y square minus 16x plus 9y minus 20 is equal to 0. Any question here?
No, sir.
We proceed with the next one then. So a very important problem also. That means circle through 3 points, circle with 2 points, passing through 2 points, and with center lying on a straight line. Such problems are important problems. Take note of such problems. Okay. Number 10. If you read this question, it states the vertices of triangle ABC have coordinates 4, 4, 5, 3, and 6, 0, respectively. Find the equation of the perpendicular bisectors of AB and BC, the coordinates of the circumcenter and the radius of the circumcenter of the circle. Now, do you know what a circumcenter is? How to construct a circumcenter? Do you know? You have not done in class 10, right? I had not discussed. Construction was out. In order to draw the circumcircle for this triangle, what we do is we draw the perpendicular bisector of this, okay? Such that this part is equal to this part. Let's call this point P. So this is the perpendicular bisector of the side AB. Also, what we do is we draw the perpendicular bisector of the other side also. Okay. Let's call this point Q. So that means this side is equal to this side. Okay. And we draw the perpendicular bisector to the third side also. But we don't normally in construction we do only two sides. But the problem here is that we'll draw the perpendicular bisector of the third side also, such that they will meet at a point. Okay. So this point here is called the circumcenter. If I call this point here, if I call this point R, and if I call this point M, the point of intersection of the perpendicular bisectors is called the circumcenter. So M here is called the circumcenter. Okay. And the distance between any of the vertices that is MB, MA, and MC. All these are called circumradius. Clear? With
Yes,
this
sir.
concept, we shall start with this sum. Okay, number 10. The coordinates of the vertices of this triangle are given. Say A vertex given here, let's say is 4, 4. B vertex, let's say is 5, 3. You can take in any order you want. C is 6, 0. Okay. And you need to find the equation of the perpendicular bisectors of AB and BC. So AB midpoint is here and BC midpoint is here. So let's draw lines through these. Okay. This is one perpendicular bisector, the other perpendicular bisector. So therefore, what can we say? This point here, let's call it M. M is the circumcenter of this triangle, right? But before that, we are only required to find out the uh, equation of the perpendicular bisector. So this, let's call this point as P, this point as Q. So that means BP must be equal to AP because this is a perpendicular bisector, and this must also be equal to this. Okay. So we can find out the coordinates of P. What are the coordinates of P? 5 plus 4 by 2, midpoint formula, and 3 plus 4 by 2, which is equal to P 9 by 2 7 by 2. Okay. Similarly, we can find out the coordinates of Q. What are the coordinates of Q? 5 plus 6 by 2 and 3 plus 0 by 2, which is equal to Q 11 by 2, 3 by 2. Okay. Now, how do you find out the equation of the perpendicular bisector through P? Let us first find out the slope of AB. What is the slope of AB? Let's call it M1. Slope of AB joining 2 points, y2 minus y1, 3 minus 4 by 5 minus 4 is minus 1. Therefore, what is the slope of the perpendicular bisector through P?
Negative reciprocal.
Negative reciprocal through P is, let's say, M1 dashed is equal to minus 1 by M1 is equal to minus 1 by minus 1, which is simply 1, right? So therefore, what should be the equation of the perpendicular bisector through P? Of the perpendicular bisector through P is, what should be the equation? You know the slope of the line through P, and you also know one point P here. What is the coordinate that we have found out here? 9 by 2, 7 by 2. So which form should I use? Point slope form, right? So y
Yes.
minus y1. Y1 here is, let's write the coordinates of P here so that we know what is x1 by 1. This is coordinates of P is 9 by 2, 7 by 2 is y minus y1. Y1 here is 7 by 2 is equal to m1 dash. This is the slope into x minus x1 here is 9 by 2. That means y minus 7 by 2 is equal to m1 dash is 1 into x minus 9 by 2. Right? Now you express this, take the LCM and take x and y on one side. Okay. And find out the equation of this circle. Is this straight line to be x minus y is equal to 1. Call this equation number 1. So we have found out the equation of perpendicular bisector through P. Similarly, we find out the equation of the perpendicular bisector through Q. So let's first find out the slope of BC. Slope of BC is y2 minus y1, 0 minus 3 divided by 6 minus 5, which is equal to minus 3. We have got the slope of BC. Now we can find out the slope of the perpendicular. Therefore, slope of the perpendicular bisector through Q. Through Q. Let's, if I call this as M2, okay, is, and the slope M2 dashed will be minus 1 by M2, which is equal to minus 1 by minus 3, which is 1/3. So we have got the slope of the perpendicular bisector through Q also. And what is the coordinates of Q we have calculated here? 11 by 2, 3 by 2. Hence, therefore, equation of the perpendicular bisector through the other point Q. What is the coordinates of the point here? 11 by 2, 3 by 2 is, and again we use the point slope form, y minus y1 is equal to m2 dashed into x minus x1. That means y minus 3 by 2 is equal to 1/3 x minus 11 by 2. Okay, and therefore therefore if you take the LCM and take everything on one side, the equation of the perpendicular bisector will be found to be x minus 3y minus 1 is equal to 0. Okay, let us call this 2. Fine. So next question here is same question, the next part of the question, in fact. Um, okay. Find the equation of the perpendicular bisector through AB and BC. This part we have finished. Next, the coordinates of the circumcenter. How do you find the coordinates of the circumcenter? See that the circumcenter is nothing but the point of intersection of these two lines. Therefore, if you solve the equation of these two lines simultaneously, you will get the coordinates of the circumcenter, right? And how do you find out the radius of this circumcenter of the triangle? Since you have know the coordinates of M, you will find out this distance by distance formula. You can get the circumradius, or you can also find out this distance, no problem. This is also a circumradius, or you can find out this distance by distance formula. Any distance you find out, and that will be the circumradius. Okay, so I'll finish this in the next class.